We're going to do example 8 on section 3.1. This one says to find the limit as x approaches 2. Example 8, find the limit as x approaches 2 for x squared minus 6x plus 9 divided by x minus 2 squared. Okay, now this one is going to be a little bit different than the ones that we had seen before in that when we try to factor this, well, first of all, notice that if you try to plug in 2, you're going to get a 0 in the denominator, so we have a problem there. So we try to factor it and see what happens. The numerator is actually a perfect square trinomial, so it's going to factor like this, x minus 3 quantity squared, and the denominator is already factored, so we're just going to leave it like that. So notice in this case that nothing cancels out. So we're going to have to go back and just do the table method. So if we make a table of values for this one, and this is pretty much sort of a last resort method if nothing else is going to work. So we'll plug in the values that are near 2, just like we had done when we started doing limits. So we'll pick 1.5, we'll pick 1.9, we'll pick 1.99, just values that are getting closer and closer to 2. And we'll go ahead and put the 2 there. You know what's going to happen. Then on the other side, we'll get close to 2 as well. 2.01, 2.1, and 2.5. So right here at 2, undefined, we'll just put a big X there. Now if we start plugging in these other numbers, and I've done this on my calculator already, so we're going to get 9 here, 121 here, 10,201 for this one. I think it's pretty clear what's going on here. We'll have 9,801 there, and 81. And the last one we get 1. So notice in this case what happens as we get closer and closer to 2 on both directions. What's happening to these y values? They seem to be getting bigger and bigger and bigger. So what do we do when we see that behavior? We basically just say, since it's doing the same thing on both sides, you see it's going to positive infinity on both sides, we say the limit is actually infinity. However, for the purposes of whether or not this limit actually exists, it doesn't exist because there's no particular value that this thing is approaching, and infinity itself is not considered a number, it's just a concept. So really, the limit doesn't exist, but when we say infinity like this, this is describing the behavior of the graph. What we would see on the graph as we approach the number 2 is that the function would just go up like this to infinity. So kind of like this. I'll just quickly graph it. So right around 2, you'd have what's called a vertical asymptote. The graph would tend to just go up the closer that we get to the number 2. So that kind of thing. So the limit doesn't exist, but we say that it's infinity just to show the behavior of the graph as we approach 2.